Good evening. In week 4, we're going to be looking at chapters 10 and 11, which deal with water and soil. I know for the most part we don't think much about water and soil because they're all around us. So naturally we don't think of them as being a valuable commodity, especially since the water falls from the sky and dirt you dig up from the ground. We don't think of it as being something that's precious. But it is all too precious if we are going to continue to be able to grow food in order to keep human population alive into the future. And so in these two chapters, we're going to look at how water is recycled throughout various ecosystems and also investigate the complexity of soil and how it recycles nutrients. So in addition to the other recycled materials that we've looked at so far, such as carbon and phosphorus and nitrogen, we're now going to look at two more precious materials that are recycled through ecosystems, namely soil and water. Let us begin with Chapter 10, an investigation of water. I'm sure all of you have heard the fact that 2/3 of the earth is covered by water, and therefore it isn't something that we necessarily think we'll ever um, use up or lose. But the problem is that water is mostly salt water. As you can see from the diagram accompanying my conversation with you, 97.5% of all the water in the world is salt water. And unfortunately, salt water cannot be used for growing things because the salt is poisonous in large concentrations, to living things. And so the water which we most need for growing things is constitutes only 2.5% of all of the water in the world. And of that 2.5%, 1.7% of it is tied up in the polar ice caps and glaciers, which means that less than 1% of accessible fresh water, less than 1% of the water in the world is accessible fresh water for the purpose of growing crops, which makes it the vital resource that it is. In this chapter, we're going to look at how water is recycled and how it is that we might someday be able to better access salt water so as to provide in an economical and reliable and mass production capacity fresh water from the saltwater supplies that we have. Let's begin with something called the hydrologic cycle. Much like some of the other cycles that we looked at with carbon and nitrogen and phosphorus, water itself goes through a number of ecosystems and travels in various ways that are important for its availability to grow things. In this particular diagram we see, or we can begin with looking at water that's housed in clouds. Clouds, in fact, are nothing more than water vapor up in the atmosphere. Under the right conditions, that water can be condensed and fall to the ground in the form of precipitation. Once it hits the ground, there are a number of different ways that water can flow. It can either soak into the ground, or it can run off the surface and down into catch basins, if you will, rivers and lakes and streams, where they eventually run off into larger bodies of water. Or some of the water can infiltrate, as it's called, into the ground. In the ground, it has the capacity to either soak into what is called the water table, which is a level in which water exists within the ground. It's the area where, if you were to live in an urban area, they would sink a pipe in order to draw water out through a well. And this groundwater then can serve as a large reservoir for future use, as we'll see further in the chapter. Some of that water may well be caught while it is still in the ground and absorbed by the roots of trees and plants and other living things, primary producers that grow in the ground, and that water then becomes part of the whole photosynthetic process that occurs within the tree and eventually can be released by the tree through a process called transpiration back into the atmosphere where it is recycled. It is also recycled by processes called evaporation and, as we mentioned, transpiration, which is water given off by plants, again back up into the air where it can be recycled over and over again. Next, we're going to look at how we manage water, primarily through the building of dams, pipelines, and wells. In the case of dams, we see that while they are an effective way of corralling and holding water and also using water to produce energy, as we'll see in a future chapter, the very fact that we are building those dams in and of itself produces environmental impacts, most of which are not very good because it causes the flooding of lands that could otherwise be used for other purposes and other kinds of environmental destruction. We'll see, as far as drawing water out of wells, that just like we tap oil out of the ground, we can tap water out of the ground. And much of this water, again like oil, is water that has been buried since prehistoric times. In fact, it's called fossil water. But like oil, it's in limited supply. And just as we will someday use up all of our oil supplies, we may someday very well use up all of our fossil water supplies. Already we're seeing the impact of the drawdown of some of this fossil water in such things as land subsistence. Every once in a while you'll see stories in the news where big sinkholes have opened up and swallowed whole buildings. These sinkholes are primarily generated by the fact that there are holes in the ground that were once filled with water, and as the water was used up, the hole became filled with air instead of water, which was insufficient to hold the buildings up, and hence they collapsed. So water, just like oil, is a limited commodity at the moment, and how we deal with that is going to be important for how long it lasts. So, how do you make it last longer? Well, just like with oil, you basically have two choices. Either you use less of it, or you find new supplies. As far as using less water, basically the areas to focus on are agriculture and commercial and home use of water. In terms of agriculture around the world probably is the largest consumer of fresh water. However, a lot of that water which is used in irrigation is wasted because of the methods by which the water is laid down onto the ground. Most of the water ends up soaking into the ground instead of getting to the plants that it's being put there for. So improvements in agricultural use of water will go a long ways to helping us to conserve and extend the supplies that we have. In terms of home use of water, there are a number of things that each of us can do around our own home to conserve the amount of water we use for the purpose of washing, as well as for gardening and other purposes of that nature that will help us to both decrease our water bills as well as help improve the environment. With regard to finding new sources of fresh water, the greatest potential asset for that is, as I mentioned earlier, desalting salt water to produce fresh water. The key to that, of course, is doing it in a cost-effective manner. And in the book, we're going to look at some cities, primarily Tampa Bay, which have installed huge systems like the one in the accompanying illustration with my discussion, which are capable of taking salt out of, in this case, the salt water from the Gulf of Mexico to such a degree that the fresh water that's produced is sufficient to supply the needs of the entire city of Tampa Bay. And all of this, as occurs in almost all the chapters in this book, is going to be impacted by legislation and public policy. In order to encourage people to conserve water, there have to be laws such as various municipalities have for not allowing people to water the lawns during the hottest parts of the day, as well as different laws to encourage conservation of water, production of water, and appropriate use of water. That brings us to Chapter 11 and the study of another important resource, namely soil. As we will see, soil is not simply dirt. Soil is in fact a complex mixture of organic material that comes from dead living plants, stems, flowers, and other seeds that provide nutrients that become part of the soil, but that also require the presence of minerals that comes up from bedrock, all stirred together by the interaction of living organisms that mix and aerate the soil so that it can become good material for growing things. Unless you have all three of these components, to make up the dirt, you will not have good soil for growing. In this chapter, we're also going to look at what happens when soil is degraded, what kinds of processes cause soil to become so badly destroyed that it can no longer serve as a source of nutrients. One of the things that causes soil degradation, as shown in this photograph, is what happens when you irrigate land using salt water. As I indicated in the previous chapter, salt in high concentrations is deadly to plants, and when you have soil impregnated with high amounts of salt because of saltwater irrigation, that soil becomes essentially useless for the purpose of producing food. So looking at different ways of looking at different processes that cause soil degradation is important to understanding what we can do to prevent it. We're also going to look at different ways of conserving soil, different ways of farming, different ways of managing, different ways of supplementing nutrients to soil, all of which will help to maintain a good mix of all the appropriate nutrients in the soil so that it can produce food. It also involves managing the soil so that it's not lost. So things such as we see in the accompanying photograph, processes such as contour plowing that decreases the amount of soil erosion that might occur due to water runoff on sloping lands, are also important to conserving soil and making it last longer so that it's available for the growth of food. And finally, we're going to look at various laws and public policies that are being put in place to, like water, help conserve soil, to make sure that it is properly looked after, that it is not eroded off into streams and lakes where it causes other problems, and to find better ways of managing our soil so that it continues to be healthy, productive land for growing crops and supporting future generations. So that's it for Module 4. I hope you find it as interesting as I have, and I look forward to reading some of your discussions and your blogs and your responses as always. Have a good evening.